Have you noticed that when you call an elevator and you push the button 3 times, only one elevator arrives? What is the correspondence with software design? Well, this is what we'll talk about today. 2 ways to simplify your design. One is pure functions and the other one is idempotency. Yeah, a big word. But we'll discuss this in detail. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today we'll talk about my favorite Bob Dylan movie, which is I'm Not There. It's a very interesting movie. Oh, sorry. No, I meant we are going to talk about simplifying our designs. I got confused. We'll simplify our designs in general in software development by setting up constraints. This is weird for programmers who want to be very free and do whatever they want, but really the best ways to obtain good design is by adding constraints to the way you write code. And we'll talk about 2 types of constraints. First one is pure functions. A pure function is a function that doesn't change the state of the system. So it doesn't do any input output. It doesn't modify variables in your context. And whenever it receives the same input parameters, it returns the same output value. This is the definition. And now you may be wondering, Alex, do you have a favorite pure function? Yes, I do. Thank you for asking. Why are you surprised? So yes, I do have a favorite pure function. My favorite pure function is the identity function. That is a function that receives an object, no matter what type it is, and just returns that value. This is a brilliant function because it's just perfect. It's the perfect embodiment of high levels of abstraction, of polymorphism. It's very hard to write a function that's more polymorphic than that. You just pass in the value you want and you get the same value. Now, is it very useful? Well, it turns out it is not as useful as other functions, but it is quite useful in many contexts for simplifying things. But let's go back to pure functions. Why are pure functions useful? Well, pure functions are useful because they are predictable. You pass in values, you get in output. Some examples are the normal operators that we use. Boolean operators, right? You know exactly. You pass true and false, and the function is AND, you get false. Always. It's not a matter of what's in the system. You addition, you pass 1 plus 1, you always get 2, no matter what else is happening in the system. They are very predictable, they are boring, and therefore they are really good for simplifying your design. But we did a whole video on pure functions, so I'm not gonna go into a lot more details than that. Generally, the implementation of pure functions differs on your language. You can have it less constrained or more constrained. The less constrained version is just you being careful to follow, to make it a pure function. This is what you'll do in languages like Python. In languages like C++, you can specify it's a const, it's a static, you can make, or it's a const function, so it doesn't change anything in the object that it's part of. You can do a lot of these constraints depending on your language. Pure functions also have an additional benefit beyond being really easy to understand. They are really easy to test, because you can just have a table of values, you have the input parameters and the expected output is just a data-driven test with basically a table of inputs and expected outputs. So they are really good, they are boring. One additional technique that comes up with pure function is something called memoization, which will be interesting when we talk about our next topic. And memoization is about taking advantage that you're using pure functions to optimize your system. So if inside your pure functions the computations are difficult, take long, they are complex, they take a lot of CPU or whatever, one thing you can do is to cache the inputs and to cache the output. And whenever the function is called, you verify that the function, you verify first that you have a value in the cache. Have we already seen the method being called with these values? And if so, you return the cached value. And you can do that because pure functions are predictable. They just return the same thing for the same input values. And this takes us to the next technique, which is called idempotency. You may have heard about idempotency in the context of APIs, REST APIs, HTTP, verbs, or in the context of events. Whenever you have a message queue, there's a problem. The message can be sent twice. And you do not want to have the same thing happen twice. You don't want, when you push two buttons to get twice the call button for the elevator, to get the two elevators instead of just one. So what do you do about that? Well, you have this notion of idempotency, which is a close cousin with pure functions. Why? Idempotency is about changes in the system, but what it says is whenever you get the same input values, you make the same change in the system. And that's idempotency. And this is very interesting because for systems, distributed systems, where you might get duplicated calls, this is what you want. Now, the way this is usually implemented is by caching the input value or something from the input value. Maybe it's a message ID, a transaction ID, maybe it's the input arguments, and if the return value, so if the operation was already executed, you just return the same return value. So you see how this is very close to pure function and memoization, but with one small difference. Idempotency is about caching things that affect state, while memoization is about optimizing pure functions, which don't affect state by definition. And these two techniques, if you apply them together for parts of the system that are pure, you can have pure functions. For part of the systems that need to modify state, you can have idempotency. They simplify a lot your system because these types of functions are much easier to understand, easier to test, easier to optimize, and so on. What this means is, again, constraints are really benefic for our designs. You may have seen idempotency in the context of REST APIs. Maybe it seemed like a weird topic, maybe it's a chore, but think about what it would mean to apply that inside your system, even if it's not a REST API, even if it's not a distributed system. These two techniques together can make a very powerful and simplified design. So this is what I wanted to talk about today. And if you have any questions, comments, as usual, let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.